In case study 5, we're investigating the effects of interventions at the catchment scale on river ecology. One of those interventions concerns agricultural practice and what would be the effect on the loading of nutrients into the river of implementing various agri-environment schemes. Another intervention concerns limiting light into the rivers. Because algal growth depends on light, you can limit its growth by reducing the amount of light or increasing the amount of shading across the river. And this can be achieved, at least in theory, by growing more trees. We can simulate in the model the effect of growing trees by reducing the light that impacts the river system, and seeing what effect that has on algal growth. Some of these intervention measures, we need to estimate what their effects will be by running a model on the catchment to say what will be the loads, for example, of nutrients that are going into the river, and then using that loading on another model to predict the effects of growth on algae. So we have two models providing input into the Questel model. This means we have two estimates of what the effects of our interventions in the catchment are likely to have in terms of loadings on the river. So because we have these two different models, we can investigate what effect that might have on the resulting algal concentrations. So for example, we can see whether one of them gives you a larger response or one gives you a smaller response to essentially the same set of mitigation measures on the catchment. Another benefit of using these two models, CaMMP and CaMMP, is they are intrinsically different. So whereas CaMMP takes a very holistic view of the catchment, looking specifically at land types, and derives its inputs into the river system based on rainfall data directly, SAGIS uses a set of predefined data sets to generate its loads into the river system. Also, CaMMP works at a daily time step and SAGIS is a monthly time step. It'll be interesting to see whether there's a significant difference on the river simulations when you use data which is essentially at different timescales. And it might be of particular significance more widely if we can get away with using monthly data to drive our models rather than having to go to the detail of daily simulations. SAGIS is part of a national program used by the Environment Agency for estimating source apportionment, that is, allocating the loadings into rivers based on where they come from. It's joined or linked to another model called CaMMP, which is a river simulation model, and the pair together are able to look at where the sources of pollution are and then calculate where a fair apportionment of those loads should be made in order to reach particular quality objectives in the river. So if we're able to know what the effect of using, say, monthly simulations from the CaMMP-SAGIS model is on algal growth, it implies that those national models of the Environment Agency might be more broadly applicable as providing input data to a range of models without perhaps having to manufacture a bespoke model for every new catchment.